All right, we're going to go ahead and get started. Andrea, are you on? Andrea, can you hear me?
Yep, we're here from the library.
Awesome. So I want to thank you all for coming today in Newcastle. And this is in partnership with Ford City Library. And so Andrea is joining us from Ford City as well. And so this collaboration between Ford City and Newcastle is actually two of Will's, Dr. Armentrout's, two towns that he's really come from. I guess Lawrence County can claim him because he went to Westminster, but Ford City claims him because that's his hometown. So I really want to thank Dr. Armentrout for tuning in on the weekend while he's officer training in California. And I'll hand it over to Katie to say, or Katie or Andrea from Ford City, if there's any other items that they wanted to add.
Hi, this is Katie. Can you hear me?
Yes.
Okay, I'm so sorry. I don't think my video is working, but I just wanted to say on behalf of Ford City Public Library, thank you, Dr. Armentrout, so much. This is such a special opportunity for us, and we're excited to learn all about what to expect and how to prepare for the solar eclipse coming up. So thank you, everyone, for attending, and for Newcastle for helping coordinate it.
Awesome. So we'll hand it over to Dr. Armentrout, and he can start us off. Thank you, Will.
Thank you, Andrew. Thank you, Katie. Thank you, Andrea. Thank you to the Ford City and Newcastle libraries. An eclipse is an exciting event, and so I'm very happy as your friendly neighborhood astronomer to help guide you through what you might expect over the next few days as you prepare for the eclipse and then hopefully get to see it as well. So if you are interested in seeing these slides afterwards, I'll have this link up again at the end, but I always put my talk slides up online, so you can find them at slides.com/willarmentrout/eclipse 2024, and I'll post that in the chat at the end as well. Now, I like to start most of my talks with introductions, where I come from. So it's already been discussed that I'm from Ford City and I went to Westminster College, but we'll lay out a little bit more of my path to where I am, and then talk about what eclipses are. So you might have heard about lunar eclipses, solar eclipses before. We'll walk through some of those. And then we'll talk about how you can safely view the sun on Monday, right? You may have heard in the news or from different people that it can be dangerous to look at the sun, right? You've probably been told that since you were 2 years old, 3 years old, don't look at the sun. Well, on Monday, we're going to be saying, look at the sun, but do it safely. So we'll talk about how you can safely do that. And then finally, we'll end with what you might expect as you go out to watch the eclipse on April 8th. Now, you might expect some cool things to happen in the sky, but you might not expect that traffic on I-79 will probably be a nightmare. So we'll talk about how to prepare for those types of things as well as you go to watch the eclipse. For some introductions, again, I am from Ford City, Pennsylvania, from just up on the hill in Manor Township. Went to Ford City High School, graduated in 2008. Let's go Sabres. Before going to Westminster College in Lawrence County, where I majored in physics and minored in math. So I had some great time there. And that's really where I started to move into the professional world of astronomy. So Ford City had a planetarium, which is really uncommon for high schools. And then I transformed that work into some more professional level research at Westminster before going to West Virginia University for graduate school, where I got my PhD in physics with a focus in astronomy and astrophysics. Most of my research has been on studying the structure of the Milky Way, trying to get a complete picture of what our home galaxy looks like. So that's a bit different from what we're going to be talking about the rest of today. But after West Virginia University, I went to the Greenbank Observatory, which is in West Virginia as well, deeper into the mountains, where I was a postdoctoral fellow and then brought onto the permanent scientific staff. So that's where I am in my capacity as a scientist. But Andrew also mentioned that I'm away in California right now for some officer training. I'm also in the Air Force Reserves and will be moving over into the Space Force here pretty soon as a space operator. And what that means is that I take care of satellites as well. So as a scientist, I care about stars. As a space operator, I care that our satellites as a country are all operating well, and that if someone tries to interfere with them, that we can stop that interference from happening. So we can ask more questions about that at the end if you're interested in that Space Force, Air Force kind of work. But that's my path to where I am today. Started in Ford City, went to Westminster, went to graduate school, and here I am now. Now, I mentioned the Greenbank Observatory. Here's a picture of our main telescope. It is the largest movable structure anywhere in the world. It's 485 feet tall. It is the largest movable telescope in the world as well. So you could easily fit a football stadium in this dish here. So it's this behemoth structure. It's about 4.5 hours south of Newcastle and Ford City. So if you're ever looking for a good weekend trip, go down there. There's some other cool stuff in the area as well. Train rides, things. The reason that we have an observatory in that part of West Virginia is because it is very remote and it is shielded from a lot of the kinds of interference that we make in our daily lives. Your cell phone puts out signals, your microwave puts out signals. In Greenbank, we have ways of protecting our instruments from those types of man-made radio signals that would interfere with the kinds of light that we're looking at from astronomical sources. So there's where I am now at the Greenbank Observatory. And again, if you have more questions on this or how to visit, we can ask that at the end. For now, we're going to get into the meat of today's talk, which is all about eclipses. Now, what is an eclipse? Well, an eclipse is basically the moon or the earth passing in front of the sun and creating a shadow on the object behind it. So either the moon can pass in front of the sun and create a shadow on the earth, and that's called a solar eclipse, or the earth can pass in front of the sun and create a shadow, and that's a lunar eclipse. Let's get more into those two types. So in a lunar eclipse, we have the sun over here, we have the earth then next, and the moon on the other side of the earth and sun. So just like with anything, if you shine a flashlight on an object, it's going to make a shadow behind it. That's basically what we have here in this scenario. The sun is shining light towards the earth in every direction, pretty much, but the earth then is casting a shadow behind it. And sometimes the moon will be on the perfect path and it will go through that shadow. And when it does, it turns dark. It doesn't turn black exactly, it turns red because a little bit of light is able to bend around the earth and illuminate the moon. So we have the moon here passing through the earth's shadow. It goes dark. And whenever this happens, you can see the lunar eclipse from anywhere on the earth where you can see the moon, right? The shadow is across the whole moon. So anywhere on earth where you can see that moon, you can see this lunar eclipse. Sometimes this is also called a blood moon. If you hear in the news about a blood moon coming, this is how lunar eclipses have been rebranded over the past 10 years or so ago to make them seem a little bit exciting and exotic. But anytime you hear someone talking about a blood moon, it's just a lunar eclipse, right? The moon passing through the Earth's shadow and turning dark. Now, what else can you see on this diagram? Well, you have two different levels of the shadow. You see something called the umbra, which is the darkest portion of the shadow. And then you have the penumbra, which is sort of this fuzzy outer portion of the shadow where it will be still shaded some, but it will still also be illuminated partially by the sun. So in the news, you might hear about umbras or penumbras of shadows. That's basically what it means. Umbra is the darkest portion of the shadow. Here's a beautiful time-lapse image of a lunar eclipse from a couple years ago. You can see the moon originally was fully lit. As it moved forward in time, it started to move into the Earth's shadow. Eventually, it was entirely within the Earth's shadow. And you can see it turned red here, a lunar eclipse or a blood moon, as they talk about in the news. And then it moved back out of the Earth's shadow. So every year we can have somewhere between 0 and 3 lunar eclipses. And these are always during a full moon. You might ask, why does it have to be during a full moon? Well, in order for the moon to pass through the Earth's shadow, it has to be on the opposite side of the sun from the Earth. So you have to have the sun, then the Earth, and then the moon can pass through the Earth's shadow if it's on the opposite side from the sun. The next lunar eclipse that we're going to have is this fall, September 18th. But I will tell you, it's almost not worth watching this lunar eclipse. If you want a really great one, go outside next March 15th. You're going to have to wake up super early at 2:58 a.m. Eastern time is whenever it is going to be at its best. But you will see pretty much this image that you see above. You will see the moon fully going into the Earth's shadow, turning dark, turning red. So that will be a really spectacular lunar eclipse if it's clear out. This one in September, the moon will just barely pass through the Earth's shadow. So only a little edge of the moon will be shaded. So if you want a really great eclipse, you're going to have to wait a full year for the next good lunar eclipse. What's that one going to look like? Well, here in the center here, this red circle is the Earth's umbra, or the darkest portion of its shadow. And you'll see that the Earth is going to pass fully into that umbra. And between 2:30 a.m. and 3:30 a.m., it will be entirely red. So again, March 15th of next year. Set an alarm now, wake up extra early. We've talked through lunar eclipses now, and those are super cool things to watch, but I will tell you that there is nothing in the world like watching a solar eclipse. So we have some of the same kinds of ideas here with the solar eclipse. You have to have something to create a shadow, but in this case, it is the moon that is casting a shadow on the Earth. So you have the sun shining light towards the moon casting a shadow, and a tiny little portion of the Earth being completely shaded by the moon. So we talked before about the umbra and the penumbra. Again, the umbra is this darkest portion of the shadow. You can see that only a tiny little bit of the Earth is in the darkest portion of the shadow. And that's where you would have a total solar eclipse, where you would be in the path of totality, as you might have heard about on the news. Everywhere in this fuzzier version, in this penumbra, you're still going to be partially shaded, but the sun will never be fully covered by the moon. So Ford City and Newcastle will both be in the penumbra, meaning you'll still see the moon go in front of the sun, but it will never be entirely blocked out. And we'll talk through that a little bit more here a little bit later on. So solar eclipses, total solar eclipses, are visible from just tiny areas on the Earth at a time. Here's a picture of a solar eclipse from a few years ago. Again, the sun was visible in the sky. You can see the moon starting to cover the sun until it is fully covered. And you see this bright ring of fire around the sun. We'll talk about what physically that is in space. And then the moon starts to move away, moves away, moves away, and the sun again becomes uncovered. In any given year, you can have about 2 to 5 solar eclipses, and these are all during new moons. So a new moon is whenever the moon looks dark in the sky. Well, why does it have to be in a new moon? In order for the moon to cast a shadow on the Earth, it has to be between the Earth and the sun. And so whenever the moon is between the Earth and the sun, the side that we can't see is what is lit up, and the side that we can see is the dark side. So that's why new moons always are what you have to have during solar eclipses. So when are the next solar eclipses in the US? Because they only go across small portions of the world at a time. I said you can have 2 to 5 per year, but those are going to be all across different parts of the world. So the next solar eclipse is Monday, right? And it's going to be peaked at about 3:18 p.m. Eastern time. This is going from Texas, starting and going out of Pennsylvania. I'll say this 3:18 p.m. This is the time that it will be peaked in Western Pennsylvania. So at different parts of the country, it will be at different times. But after Monday, your next chance to see an eclipse in the US is going to be in 2044, August of 2044. That one will go into Montana and North and South Dakota. And then just the next year, you'll have one that again goes from coast to coast. So it's starting on the West Coast and it will go the whole way over to the East Coast. So if you don't see it on Monday, you're either going to have to take a trip to another country to see an eclipse there, or wait until 2044 to see the next one in the US. The fact that we even have eclipses is pretty spectacular, though. The sun is so much bigger than the moon. You might ask yourself, why is the moon able to block it out? Well, the sun is about 400 times wider than the moon, but it is also about 400 times further away. So when you look up at the sun and the moon in the sky, they appear to be the same size, only because the moon is so much closer. So they appear to be the same size in the sky, and the moon is able to perfectly cover up the sun and create a solar eclipse. It hasn't always been this way, though, and it won't always be this way, because the moon is drifting away from the sun at a pretty small rate, about an inch every year. It gets 1 inch further away. And so if we do the math there, in about 500 million years, the moon will be too far away to cover up the sun. So we will no longer have eclipses. If you're able to pop back in about 500 million years to check on this, you're not going to be able to see any solar eclipses. So here on the Earth right now, we live in a golden age for eclipses. The moon used to be closer to the Earth, and so you had a lot more frequent eclipses. But as it moves further away, they'll become less frequent until we can't have them at all anymore. Right, so we've talked about what eclipses are. Now, how can you safely view them? Specifically, how can you safely view a solar eclipse? There are a couple different ways that you might have heard about on the news or from friends. You might have heard about eclipse glasses. So I have a pair of eclipse glasses here. When I put this on, I can't see the screen at all, right? It's blocking out the majority of the sunlight, majority of the light from around me. And so that's good because the sun is very, very bright, and you want to block off almost all of the light, just allowing a little bit into your eyes. So eclipse glasses are one way. You could also make an eclipse viewer. That's what this woman here is looking through. Seems kind of funny. She's just holding a box up to her head, but I swear there's a purpose for it. And we'll talk about how to make one of those. You could also just use a colander. So you likely have a colander in your kitchen. And we'll talk about how that might be useful in ways other than straining spaghetti. Right? And finally, you can look at the sun during totality if you are in the path of the total solar eclipse. So let's step through these one by one. If you have a pair of these glasses, make sure that they are ISO certified. So on the inside, it probably says something like, meets the transmission requirements of ISO 12312, something like that. They should have on there that they are certified by a board that says, yep, this is going to block enough light coming through it. So step one, make sure that there's something on it that says they are ISO certified. Step two, if you want to double check, you could put them on and look around and see if you can see anything. Again, I said I can't see anything looking through these right now, but if I look up at the lights above me, I can see some of the filaments in those light bulbs. That's a good sign. If you can look at a light bulb and see the filament, then it's blocking off most of the light. And you could also then, after you've tested this on a light bulb, go and look at the sun briefly maybe just for a couple seconds. Make sure you can see the bright outline of the sun. Then take your glasses off, look away. Make sure that there's no burned in image of the sun on your eyes. You know how whenever you look at something really bright, you can still see that bright thing for a couple seconds afterwards. With these glasses on, if you look at the sun, you shouldn't be able to see a phantom image of the sun after you look away. So the majority of the glasses I have seen come out recently have all been safe, although in previous years, there have been companies making counterfeit glasses. I know that all the glasses that were sent to the libraries have lenses that were made in the US and were ISO certified. So if you have one of the library's lenses, you should be good to go. I will say you can't just use regular sunglasses for this, right? Regular sunglasses block out some light, but they don't block out nearly enough light for you to be able to look at the sun. I have also heard of people using welding glasses as a way to look at the sun, right? Because it blocks off the vast majority of light. And so if you have welding glasses and want to use those, you might want to do some extra checks on those before using them, but that could be an option for you as well. So here is a picture of what you would see if you held your glasses up and you looked at the sun during the eclipse. You should see just the crisp image of the sun. You shouldn't see any light around it. That's a sign that your glasses are doing what they're supposed to do. But you don't have to just use these glasses on your eyes. You can also use them on your phone camera. If you want to take them and just put them over your phone camera, take an image, you'll be able to get a pretty good picture probably of the sun. So use them on your eyes, use them on your phone, but you should not put your glasses on your face and then think, oh, I want to see a brighter image of the sun. I'm going to use binoculars too. Because those binoculars are going to focus sunlight, and focusing sunlight with binoculars can start fires. So imagine what that could do to not only just the plastic of the lenses, but to your eyes. You don't want to do anything that's going to be focusing the full strength sunlight down to your eyes. So use these, but do not put these glasses on and then try to look through binoculars as well. You could severely damage your eyes that way. We've talked a lot about these glasses. What are some other things that you can do? Well, you can make an eclipse viewer. This is that box that lady was holding up to her head. And this is pretty easy to do. You might have also heard of this as a pinhole camera. And you can make this if you have a cereal box, some white paper, and a piece of foil. So I'd encourage you to look up online, maybe some ways to do this, but you pretty much just have to cut out 2 holes in this box. So on one of them, you would put a piece of foil across, and in the other hole, you would just leave it open. And if you want, you can put a piece of white paper at the back side of the box to act as your screen. You're basically making a projector screen in here. And then you're going to poke a tiny hole in that aluminum foil with either a pin. You could start with a pin, and if that doesn't give you a good image, move up to a small nail. And you're going to position your box so that sunlight can go through that tiny little hole and make an image on the white paper in the back. Then you will look through the other hole and be able to see a nice crisp image of the sun. So the bigger the hole you make, the more sunlight you're going to let into your box. If you make it too big, it's going to start getting fuzzy though. So you might want to experiment around and see what size of hole works best for your eclipse viewer box. So this is a cheap way to look at the sun if you don't have one of these sets of glasses. Another kind of strange way that I mentioned was that you could use a colander or anything that has small little holes. Maybe a cheese grater would work. Anything that has just a bunch of tiny little holes. And you're basically making the same thing we just talked about here for your eclipse viewer, but using something that you already have in your kitchen probably. So all of these holes in a colander are going to act as those little pinholes that you could make in your eclipse viewer camera, and they're going to project images of the sun through them. So here is a colander that someone used during the last eclipse back in 2017. They held it up to the sun. The sun shone through all of those holes and made tiny little images of what it looked like with the moon in front of it. So if the moon weren't there, these would be full little white circles, but the moon was partially covering the sun at that point. And so you see all of these little crescent shapes of what the sun looks like with the moon half in front of it. So this is a fun way to be able to look at it with a bunch of people all at once, because you can hold up the colander and people all around you can see the images of the sun cast from that pinhole camera setup. Our final way to look at the eclipse, so we talked about glasses, pinhole cameras, we talked about colanders. This one only applies if you are in the path of totality. So for Western Pennsylvania, that would be up towards Erie, and the sun is fully covered by the moon. So there's going to be about a 5-minute period where the moon is totally blocking the sun. So if you're in the path of totality and the sun is covering the moon, then you can take your glasses off and you can look at the sun with nothing on your eyes. You can stare right up at it. The vast, vast majority of the sunlight is being blocked by the moon, and there's not enough light coming through that could hurt your eyes. So it will basically be nighttime at that point. However, once the moon starts to go away from the sun, starts to unblock it, put your eclipse glasses back on, because even just the tiny sliver of the sun can cause damage to your eyes if you stare at it for too long. So let's recap some of our safety reminders. 1, you can damage your eyes by looking directly at the sun without protection. You can also damage your eyes by looking at the sun with these glasses on if you try to focus the light onto the glasses. So don't use binoculars if you have these glasses directly on your eyes. Number 2, wear your glasses while looking at the sun. Only take them off if you're in the path of totality and the sun is fully covered by the moon. It sounds like we're making a lot of rules here, but in general, the rule is don't look at the sun unless it is fully covered by the moon. All right, so we've talked through all the safety steps, and we'll recap those again at the end, but what might you expect on April 8th? So you've probably seen something like this map. This is a map of the US with the path of totality shown here. Everywhere in this dark band is the path of totality. So it starts in the US in Texas, goes up through Oklahoma, a little bit of Arkansas and Missouri, Illinois, Kentucky, Indiana, Ohio, and then into Northwest Pennsylvania, up here by Erie, and out through New England. So as you move further away from this dark line, the eclipse becomes less and less full. So in Newcastle, you're a little bit closer to totality than Ford City is. So Newcastle, it will be slightly more blocked than in Ford City. And then if you come down here to like North Carolina or someplace further away from that line, it will become less and less blocked. I am in training out here in California. So for me, the eclipse is the moon is only going to be 40% covering the sun. Here's another way to look at the eclipse path, though. So this is a map of Airbnb occupancy rates on tomorrow night. So red means that every Airbnb in that neighborhood is entirely booked, and blue means that there's only a 10% booking rate. So you can see everywhere in path of totality, pretty much every single Airbnb has been booked. And many of these have been booked for a long time, months or even up to years in advance. I know people who booked Airbnbs in the path of totality 2 years ago, right? So this is kind of a fun way to see the human impact of the eclipse. There are going to be a lot more people in this tiny sliver of the country than there are whenever there's not an eclipse. So what does that mean? Well, all those people have to get there. And so traffic you can expect on roadways leading to the path of totality will probably not be great. In August 2017, a lot of the interstates that were used to take people into the path of totality slowed down to a standstill at some points. So if you are planning to go into totality, I would recommend that you try to go very early. Totality in Western Pennsylvania, again, is going to be around 3 p.m. So you're probably going to want to leave pretty early in the morning. Maybe plan to spend a lot of time up in Meadville or Erie after you get there. I might recommend leaving at 5 or something like that. But you figure out what would work best for you, because a journey that would normally take an hour might take 2, 3, 4 hours, depending on where you are in the country. One quote from a fella at the American Astronomical Society was that having a total solar eclipse pass through the US, it's kind of like having 20 or 30 Super Bowls happening all at once. So Super Bowl traffic can be pretty bad, pretty gnarly, but that only happens in one city. This is happening in many cities, many places all across the US, and a bunch of people are going to be trying to get into that path of totality. So I very much recommend trying to see the eclipse in totality, but just know in advance that it will be a little bit harder to get there than it normally would. You also might want to check the weather. So I checked last night, and for Erie, it said that the weather was partially cloudy. I would say check the weather, but be adventurous. So eclipses we talked about are very rare events. And even if there's potentially poor weather in the cards, you may still want to take the chance. This picture on the right is of me during the 2017 solar eclipse. My family and I went down to South Carolina, to Charleston, to see the eclipse because that was in totality at that point. And that day, we had thunderstorms. The entire sky was cloudy up until 20 minutes before the eclipse, when this tiny little circle of clouds opened up with the sun right in the middle. And we were able to see totality perfectly. Now, as soon as the moon covered the sun, it was kind of apocalyptic. The sky turned dark. There was lightning because I said we had just had thunderstorms. And I kid you not, there was lightning as soon as the moon covered the sun. It was a wild experience. Animals started to act differently. Wind changed a little bit. But even just a couple miles away from me along the beach in South Carolina, the hole in the cloud was not perfectly over the sun. So people over there didn't get to see the eclipse. So what I'm saying is that you may want to take the chance and try to see the eclipse, even if it says that there could be patchy clouds or something like that, because it is that much of an awesome experience. Now, what will you see in different parts of the country? So I focused on Ford City, Newcastle, and Erie here, and I will put this link into the chat and we can go through it a little bit at the end of the talk. But in Ford City, you will have a partial eclipse. The sun will be 96% covered by the moon, and the peak time there will be around 3:19 p.m. So you see this tiny little sliver of the sun here on the left side of this image. That is enough sun that you still need to wear your glasses, your eclipse glasses. Unless it's 100%, you need to be wearing your glasses. In Newcastle, you're a little bit closer to the path of totality. It will be 98% covered. The sun will be 98% covered. And the peak time there is around 3:18. Newcastle, the sky may get a little bit darker. It will still not feel like nighttime, but the sky may get a little bit dark. And this tiny little sliver of the sun, that 2%, you still need to wear your solar glasses if you're looking at the sun. In Erie, however, you're in the path of totality. And at 3:18 p.m., for about 5 minutes around that time, the sun will be fully covered. And you can take your solar eclipse glasses off at that point and look right up at the sky. We're going to talk more about what some of the things you see around the sun are here in a second. But in Western Pennsylvania, the partial eclipse begins around 2:06 p.m. and it will end around 4:30. So here is what you will see in Western Pennsylvania. This is taken from Ford City, but Newcastle is going to look about the same. So you see the moon is moving in front of the sun, almost fully covers it, but there's still a little sliver of the sun visible, and then it will start to move away. So you have about 2.5 hours where you're going to see part of the sun blocked by the moon. So you have a good long range there where you can go out, maybe check it a few times to see how the moon is moving across the surface of the sun. And on this image, you can see there's a little sunspot there. I'm not sure what sunspots will be there on Monday. These change sort of daily, weekly, but you might see if you can pick out some dark patches on the sun that are sunspots. So the sun is emitting a little bit extra radiation from those regions. You can think of those as tied to to solar storms. Now, if you're in the path of totality, what else are you going to be able to see? Well, you'll be able to see the corona, which is sort of this bright white ring around the sun. That's the sun's outer atmosphere, and it is much, much hotter than the surface of the sun, but it's also much fainter than the surface of the sun. So whenever we're looking at the sun normally, we can't see the corona because it's all blocked out by the rest of the light coming from the sun. So the surface of the sun is about 6,000 degrees, which is hot, but the corona is about 1,000,000 degrees. So much, much hotter. You can also see right before and right after the eclipse ends, this diamond ring effect. So that is just the very last moment before the sun is fully covered by the moon. You have this last little glint of the sun, and it kind of makes the eclipse look like a diamond ring, right? So here's the band, and here is the ring. One of the coolest portions, I think, are called these Bailey's beads, which if you look around this image, you can see these little bright spots. These are areas where there are maybe craters on the moon or mountains on the moon, and you're seeing sunlight pass through those craters on the moon to get to you. So I think that that's super cool that you can use the eclipse as a way to map out different portions of the moon itself. But don't just look at the sun if you're in the path of totality. It will be nighttime in totality. We talked about being in that total path as being an awesome, like, otherworldly experience. You're going to be able to see planets in the sky. You'll be able to make out Jupiter, Venus, Saturn, Mars. And there's also a comet that's going to be potentially visible near Jupiter here. So if you're in that path of totality, look at the sun. It is an amazing feat, but also see if you can pick out other things up in the sky. Now, let's think about what's on Earth, right? What are you going to feel? What are you going to hear? Well, you may hear animals acting, or you may see animals acting kind of strangely. There was an experiment in 2017 during the solar eclipse that saw that about 75% of zoo animals exhibited behavior changes that resembled nightfall behavior or anxious behavior. So you probably don't have giraffes that you're going to be around during the eclipse, but giraffes just started to spontaneously gallop. They had no idea what was going on. They were probably feeling anxious, so they started galloping around. Dogs, you're maybe more likely to be around some dogs. Dogs tended to go fairly silent. They weren't sure what was happening, and they just retreated into themselves to see what was going on. Horses kind of cluster together and shake their heads back and forth. Gorillas in the zoos put themselves to bed. They said, "Oh, sun's gone. Let's go. Time to sleep." Cats were unaffected by the eclipse, which I think is hilarious. Cats just went on their merry life and did whatever they were doing. They could not be bothered that a solar eclipse was happening. Birds, you may see some strange activity from birds. They may stop flying and go silent. That's what I saw during the eclipse. And then turtles, for some reason, become fairly lovesick and amorous during the eclipse. So every animal maybe responds very differently, but see if you can see some animals around you. Maybe look at your dog, maybe look at your cat if you're around. Listen to birds. What else are you going to feel and hear? Well, the weather is going to change. You're blocking off the light from the sun. You're going from daytime to nighttime pretty quickly. And so the temperature will drop, very likely. In humid places, it drops anywhere from 5 to 10 degrees. And in dry places, it drops from 8 to 14 degrees. There was one eclipse in Africa that showed a 15-degree drop in temperature during totality. So even if it's fairly warm where you are, let's say it's 65 degrees, the temperature may drop to 55 or 50 degrees during totality. So you might want to have an extra jacket or so. So the world around you is going to change. The world around us is impacted by sunlight coming to the earth. And if you suddenly cut off that sunlight, well, wind may change, temperature may change, etc. So the eclipse is kind of an otherworldly experience. And whether you're viewing a partial eclipse in Ford City or Newcastle, or going to totality up towards Erie or some other place along the path, have fun. We all get to be scientists on eclipse days and see how the world around us is changing, see new things around the sun that we don't normally get to see because it's so bright that it blocks off the corona and all of those other little aspects around the sun that we get to see during a solar eclipse. So have fun, share it with friends and family, and enjoy being a scientist for the day. Now, to recap, solar eclipses are very rare events, and the next one in the US won't be until 2044. And I think that it is very worth it to go to totality, even if your roads may be full of traffic. But make sure that you take care of your eyes and use ISO certified solar eclipse glasses or an eclipse viewer that you can make with things that you probably already have in your house. You can pull a colander out from under the cabinet and use that to make solar eclipse shadows on the ground. And if you're in the path of totality, you can look directly at the sun only when the sun is fully covered by the moon. So that's all that I have to share about the eclipse. I hope that you took away a lot of good tips for how you are going to go out and see the eclipse on Monday. So I'll turn it back over to the Ford City and Newcastle libraries, and I think we can take any questions here as well.
Awesome. Thank you, Will. We really appreciate it. Now, those individuals that are here, are there any questions that you might have? Yes, question. You might want to speak up. He can actually hear you, so go ahead.
Oh,
What's your question? I'm sorry.
it wasn't a question.
Oh, he has a question about the glasses, but you'll see me afterwards. Is that right? Or is there a specific question about these? How they work?
Yeah,
Okay, go ahead.
so, how do they really make the glasses as dark so your eyes are safe?
Can you hear that, Will?
Yeah, how do they make the glasses so dark so that your eyes can safely see through them? I don't know. I don't know the manufacturing here. I know that it is think of it as like a very, very dark cellophane that is blocking off the vast majority of light. And then if you look at the glasses, you can see that there's a mirrored finish on the outside. So they're basically a mirror on the outside as well. And they're reflecting away most of the light. And the other side, it looks dark. So it's reflecting away most of the light, only allowing a tiny, tiny fraction of that light to pass through. So I don't know the specific manufacturing process, but it's a very, very dark lens coupled with the fact that the outside is sort of a mirror. Does that answer what you're asking?
Yeah.
Okay.
Is he gonna be able to do this thing that he's in California? So somebody that he knows back here gonna give him, because that's kind of sad, he's a specialist. And he's all in California, he's not gonna get to see the event himself.
I know. Were you asking about me not being able to go to totality? I'm devastated by that. Actually, I've had plans for the past 6 years to go somewhere. But right now I'm on military orders and I'm required to stay right here. So I'm having a little party here at the schoolhouse. I brought a bunch of glasses for people around me to see the eclipse too. So it'll only be 40% here in California, but I will put plans on the schedule for 2044, and I will make sure that I can see that one too.
Right. Would that be so that you can actually have the view, even though you're not here?
She's
Um,
asking, so like, can you use a satellite to view the the eclipse as well?
Yeah, this is a great point. So there are websites that you could find live streams of the eclipse. I have some friends that are in Texas and are setting up cameras to live stream the eclipse. So let's say that you are not able to go to totality. You are at work, you can't go to see it. There are websites where you could Google live stream solar eclipse, and you could see it happening in real time from different places around the country. So that's a great point. And that's something that I'll do too. I'll go on and find one of those live streams so I can at least see it virtually.
Go ahead, sir.
Right. On that slide with the telescope, the Greenbank, I was just, who made that? Was it a university or was it a manufacturer? I used to build those things in my past occupation. I'm just curious.
Yeah, so the observatory is run by the National Science Foundation, and it is managed by a group called Associated Universities, which is a group that manages all of the radio telescopes, all of the large radio telescopes like this in the country. And I say all of them. There are really only 3 large observatories like this. There's the Greenbank Observatory. There's the Very Large Array that is run by the same company in New Mexico. And there's ALMA in Chile, in South America. So the National Science Foundation pays for the science that goes on here. It is run by Associated Universities. And then the contractors that built this, I think there were a few different contractors for different parts of it. One contractor for all of the steel work, the structural backup. I believe Lockheed Martin did the base of it, because down here, this isn't just sitting on bare earth, it's sitting on concrete that goes 40 feet down into bedrock. And then another contractor for the dish. So a lot of the people that we get to do painting also, so this structure needs to be repainted fairly frequently. You can think of it like a bridge, right? So we're talking with bridge contractors to come in and repaint this structure, because it's been about 20 years since it was built and it's in need of a new paint job.
Will, I think there was a message in the chat.
Let's look. There's a question. Are sun oculars safe to view? Let's see. Is a sun ocular the one that it's basically the same material as this, but just a wider band that you can look through? I'm going to Google this really quickly.
We think of the sun as going from east to west, but the eclipse seems to be starting in Texas and going north.
I'm just Googling. I'm not sure what a sun ocular is. If the person who put that chat in could clarify a little bit, then we'll come back to it. And I think that there was another question about the path going from east to west versus south to north. Is that right?
Yes.
Yeah, so the eclipse in 2017 went from the west coast to the east coast. The eclipse now is going from Texas up through and out the north part of the country, so going from south to north. This is just dependent on the geometry, or where the Earth and the Moon are with regards to the sun, what that total path looks like. So it's different for every eclipse, pretty much. Although those paths do repeat after so many years. So we're going to be able to predict where eclipses will be in 100 years, in 1,000 years, because they repeat pretty regularly. Does that answer your question?
More of that shit.
Will, I think there was a response on this binoculars in the chat. She said it was the white light binoculars.
I am Googling really quickly. I oh, I see. Yes. Yeah, so those I just Googled and found them. It looks like those are safe to use. So double check on the safety branding of these. The ones that I found say that they are fully safe to use, block off the vast majority of light. And the reason that these are safe is because the actual front of the binoculars have the lenses on them. So it is not focusing light, full power sunlight, and then trying to filter it. It's filtering first and then focusing that filtered light. Does that make sense? So the ones that I found say that they are safe, but your run-of-the-mill binoculars that you might use to go bird watching, absolutely do not use those for looking at the eclipse.
Well, when it's 98% coverage in Newcastle,
Mhm.
can you take your glasses off for a second just to take a quick peek? Or is it advisable not need to look at it?
The
But in that little sliver.
yeah, I mean, I would not recommend staring at the little sliver of the sun, but I off the record, right? We have all like caught the sun in our gaze very quickly as we're looking on the sky. So it can still damage your eyes if you stare at the sun for any period of time, but if you take the glasses off and just like pass by that region, I don't think that you are going to damage your eyes. Still, you're going to get a better view of the sun with these glasses on because you're going to be able to make out the features, the sharp features of the sun. Whereas even with that 2%, it's going to be the brightest thing in the sky and it'll just look like a bright point probably still.
Well, I'm not able to get off work and my computer monitor is right in front of the window in my office. And I have an exact view of the sun at 3 p.m. Is my only risk the fact that if I look up from my monitor and look directly at it, that's where I would be at risk of any eye damage?
Yeah. So the only risk is the risk that you have normally for looking at the sun, right? The difference is during eclipses, people want to look at the sun. So you're going to have the same kind of risk. There's nothing extra that is being emitted from the sun during eclipses. So it's just that bright light from the sun can go in and focus in your eyes and cause damage to the back of your eyes. So it's the same risk as always that you would have with the sun there.
So it's the same risk with any day that I'm sitting at my workstation and looking. There's nothing different to it other than human nature is going to probably cause me to want to intentionally look at it. Is that fair to say? Exactly.
Yeah. So most days you probably don't think, what if I looked at the sun today? But on Monday, you might think that. So there's nothing extra special. You're exactly right.
Thank you.
Mm-hmm.
If we are fortunate enough to get low cloud cover here in Newcastle, will we be able to see any of that corona activity or those Bailey speeds? I'm just trying to think, what can we point out as we're outside around the library trying to see this, wonderful event?
I don't think that you'll be able to see the corona in Newcastle. Whenever I went through the simulator let me actually bring up that page. It did show that Newcastle, the sky might get slightly darker. So I will pull that up here. I'm going to stop sharing on one screen and start sharing on another. And I will put this link in the chat as well. So I'm going to type in for Newcastle. And if I run time forward, can you all see this? So right here is whenever it is at its peak in Newcastle. Let's see. 318. You may see some bright planets right at that moment. If you would zoom in, the sun, you can still see this tiny little sliver. That's how much of the sun, oops, is going to be uncovered by the moon. So it seems like you are, I mean, in Newcastle and in Ford City, you are almost there. There's just this tiny, tiny little sliver of the sun that is still unblocked from the moon. But the sky may go slightly dark. You can see on this simulator, there are stars and planets slightly visible around.
Uranus.
So, yeah, you probably won't be able to see Uranus, but you probably will be able to see Jupiter and Mars right in that moment. So fingers crossed that you can see that. And the temperature will probably also still drop in Ford City and in Newcastle, right? Because you are blocking off the vast majority of the light from the sun, blocking off all of that heat. And then let's see, after 318, it continues to go forward. So if I switch this to Ford City, step it forward, right around that same time, there's a bit more of the sun that is exposed. About it's double the amount of sun exposed as in Newcastle, and the sky in this simulator at least didn't darken. So even with those tiny amounts of sun visible, I still don't think you're going to be able to see the corona. Hopefully the sky might darken a little bit. It'll still be an awesome experience to show with the colander, with an eclipse viewer, that you only see this tiny little sliver of light. So there are still plenty of cool things to see whenever you are not in totality.
Will, if we Google cosmic data stories, solar eclipse 2024, is that how we can find this?
I will email it to you, and I will also put it in the chat here. But yeah, you should be able to just cosmic data stories. And there's also a link in that presentation that I shared.
Thank you.
Yep, I will put this link in here right now for anyone who is on chat.
Well,
Yeah.
is the path of totality definitively set at this point? That there's no ability for that to wave at all. It's going to be pretty much, if you're in that shaded area that you're seeing on the screen right now, it's going to be defined exactly to that at this point.
Exactly, yeah. So here is an interactive map where you can see that path of totality. So Ford City is right over here. Newcastle is over here, so you can see Newcastle is closer. And this is the line just above Hermitage is where the path of totality starts. So Greenville is in the path. Hermitage is not part of.
I work in Hermitage, so at this point, there's no chance that that's going to end up being in the totality path. It is defined exactly. Is that okay? Thank you.
Yeah, you're welcome. So as you get closer to this blue line on this map, the path, you get a longer solar eclipse. So around the blue line, you'll have about 5 minutes of totality, and along the red line, you'll have about 2 minutes. So if you can get your office to shift north by a couple miles, then you'll be able to.
No, but I can get my car to shift by 2 miles.
Andrea or Katie, any questions from Ford City?
Can you scoot over Columbus?
Yep. So Columbus is a little bit in totality. The airport is in totality. Downtown is not.
All right, I'm driving.
Yeah. Like
it
I said,
doesn't seem like we have any questions from Ford City, but we appreciate the vantage point there and showing everything from what we might be able to see here. We really appreciate it.
So you can see here on this map what roads might get kind of harried, because people from Pittsburgh are probably all going to be taking 79 up to get into Erie, or up towards Cleveland even. So those main arteries are the ones that got backed up during the last solar eclipse. So any other questions I can answer? I'll put that link in here as well. And then I'll make sure that the libraries have that shared.
So Will, on the more personal note, how is officer training going?
It's going well. The training that I'm at right now is called Space Operations Training. So everyone in the Space Force who is a space operator goes through this training, and they teach you how to control satellites, how to prevent jamming on satellites, because that's something that happens fairly frequently. You can imagine in different conflict regions, our adversaries don't want us to be able to have satellites for communication. And so they try to jam those satellites and keep us from having that communication. So that's one of the training modules. There's also on launches. So out at Vandenberg Space Force Base, where I am right now, most of the Starlink satellites are being launched from. So every week or so, we see a rocket that was on the ground minutes ago going up to space and releasing all of those satellites. So a lot of very wide scale training on everything that the military does in space. That's all distilled into this 6-month course. And after this, I'll go to Colorado Springs for another 2 minutes of training specifically with my unit. There's a question in the chat. Whenever I switch to Space Force, will I spend any time at Buckley Space Force Base, which is the base in Denver? Potentially. There are only a few bases in the country where we have space effects. Most of those are centered right around Denver and Colorado Springs, but there's also Vandenberg in California. There are some stations in the Northeast. There's a radar station in Cape Cod. And then, of course, there are launches that happen from Cape Canaveral as well. So all of those launches always have a space operator attached to them. So a very different world of space from what I get with my job as a scientist, but a lot of compatible training as well, right? We're all looking up into the sky. Whenever I'm in West Virginia, though, I'm looking millions of light years away. And whenever I'm with the military, I'm looking very close to the Earth.
Any last questions here at Newcastle?
Well, with the future eclipses in 2044 and 2045, when does our path of totality get definitively defined, or is it already?
It already is. I tried to look that up though, and I couldn't easily find it. But we have it. It is known. Somebody knows it when the totality will be for the 2044 and 2045. I just don't, and I couldn't find it. But yeah, all of these things, like I said, are very regular, and so we can predict hundreds or thousands of years in advance when an eclipse will be, where it will be on the Earth, and what the specific path will be. It's pretty amazing, actually.
Will, this is Katie. Can you hear me?
Yep, I can hear you.
Okay, I just want to thank you too again on behalf of Ford City. And I just had one quick question. Personally, do you know, I know you talked about the animals and how it would the eclipse would affect them. If we do have a pet dog, can they be outside and look at it? Will it hurt their eyes at all? Do you know?
Yeah, I don't think that it will, because dogs know during the day not to look at the sun.
Right.
Anyway. And so there's nothing super special from their perspective that would make them want to look up at the sky.
Okay.
And see it. Yeah, so they're just gonna live their merry little dog lives until the light goes out, and then they might just be like, what's going on?
Yeah, so maybe just be with them and reassure them it's okay. But all the rest of us, wear your protective eyewear. And thank you again for that, the wonderful donation. We really appreciate it. The glasses.
Very welcome.
All right. I'm going to sign off. Thank you again so much.
Yes, and we want to thank Will, Dr. Armentrout, for tuning in all the way from California today. He did contribute the glasses that you have here today. And so here in Newcastle, we really are grateful for Dr. Armentrout tuning in all the way from there. Now, if you want to learn more about space, I did pull some Neil deGrasse Tyson and Carl Sagan, and then I also pulled the Hidden Figures book. The movie's already checked out, but if you want to learn more, you're welcome to check out those books over here. And I also have stickers from NASA. And we have the Artemis sticker, and then we also have NASA stickers. So if you want to deck out your laptop or your anything you have, your car, you're welcome to take some of these with you. So this message is being recorded, and so this will be posted on our Facebook page. And so if anyone is unable to participate today, send them a link. We'll try to get it up as soon as possible. I'll send the same link over to Ford City so that they can post it as well.
Sounds perfect.
Thank you very
all for-
much. Thanks,
thank you
Andrew.
for tuning in. And I hope wherever you are that you have an awesome time watching the eclipse on Monday.
Thank you, Will. Have a good one.
Bye. We'll see you.
Bye.